Year 10, today we're going to demonstrate the practical for rates of reaction.
There are two methods you can use. The first is loss of mass and the second is volume of gas produced. Method 1, loss of mass method. For this you will need 1 molar hydrochloric acid, calcium carbonate, known as marble chips, a spatula, a 250 centimetre cubed conical flask, 25 centimetre cubed measuring cylinder, cotton wool, a 2 decimal place top hand balance, a weighing boat and a timer. Procedure. Measure 25 centimetre cubes of 1 molar hydrochloric acid using a 25 centimetre cubed measuring cylinder and pour it into a 250 centimetre cube conical flask. Weigh out 1 gram of calcium carbonate using a weighing boat. Place the conical flask on a top hand balance. Quickly add the calcium carbonate to the acid in the flask. Put a piece of cotton wool loosely in the mouth of the flask and immediately start the stopwatch. Record the total mass. This is the mass at time 0. Record the mass at 30-second intervals until there is no further change in mass. Plot a graph of total mass in grams, y-axis, against time in seconds on the x-axis and draw a best fit line through the points.
Another way of measuring rates of reaction is by volume of gas produced. There are two methods of collecting the gas. The first is by displacement and the second using a gas syringe. For the displacement method you need 0.5 mole hydrochloric acid, calcium carbonate, 250 centimetre cubed conical flask, 25 centimetre cubed measuring cylinder, 250 centimetre cubed measuring cylinder, a delivery tube, a water trough, clamp stand and a stopwatch. We filled the trough with water and then we filled the 250 centimetre cubed measuring cylinder with water and inverted it into the trough. Use a 25 centimetre cubed measuring cylinder to transfer 25 centimetre cubed of 0.5 mole hydrochloric acid into the conical flask. Check that the bung with delivery tube fits tightly into the neck of the conical flask and place the other end of the delivery tube under and into the inverted large measuring cylinder. Weigh out 1 gram of calcium carbonate using a weighing boat. Remove the bung from the neck of the flask. Tip the calcium carbonate into the conical flask. Replace the bung immediately and start the stopwatch as soon as possible. Swirl the flask to mix the contents. Record the volume of gas in the measuring cylinder every 30 seconds until there is no further increase in the volume. Plot a graph of total volume in centimetre cubed, the y-axis, against time in seconds, the x-axis, and draw a best fit line through the points.
The second method of gas collection for a rate of reaction experiment is to use a setup like this, which uses a gas syringe. Again, the amount of gas produced is measured over time. Another way to measure rate of reaction is by colour change or turbidity.
Now we will show you how the rate of reaction is affected by concentration.
In this experiment, we will use sodium thiosulfate solution, dilute hydrochloric acid, a 10 ml measuring cylinder, a 50 centimetre cubed measuring cylinder, 250 centimetre cubed conical flask, paper with a black cross on it, and a stop clock. Measure 10 centimetre cubes of sodium thiosulfate solution and put it in the conical flask. Measure 40 centimetre cubes of water. Add the water to the conical flask. This dilutes the sodium thiosulfate solution to a concentration of 8 grams per decimetre cubed. Put the conical flask on the black cross. Measure 10 centimetre cubes of dilute hydrochloric acid. Put the acid into the flask. At the same time, swirl the flask gently and start the stop clock. Look down through the top of the flask. Stop the clock when you can no longer see the cross. This experiment can be repeated by varying the concentration of sodium thiosulfate. We repeated this with 30 centimetre cubes of sodium thiosulfate and 20 centimetre cubes of water. This gave a concentration of 24 grams per decimetre cubes. We also repeated it with 50 centimetre cubes of the sodium thiosulfate alone, a concentration of 40 grams per decimetre cubed.